Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning more about the area of polar curves. Now we're going to put multiple polar curves on the same graph and find areas inside graphs, outside graphs, and everything in between. All right, so let's get started and let's see how this is going to work. Okay, so here's the first question. What we want you to do is find the area of the region that lies inside the graph r equals 3 sine theta and outside r equals 1 plus sine theta. All right, so the first thing you need to be able to do is identify which graph is which. So 3 sine theta is going to be this circle that's up here. And then r equals 1 plus sine theta is going to be this graph here. Okay, looks like an upside down heart. All right. Now, I want to find the area of the region that lies inside this graph, this circle graph in green, and outside of this graph here that's in purple. So the area inside the one and outside the other would be this area here. So this is the area that I want to find. Okay, the area of this region. Now the question is, how do I do that? Well, the only formula that I actually have to work with is I can find the area of a region by taking 1/2 the integral from alpha to beta r squared d theta, right? That's how I can find the area of a region underneath a polar curve or of a polar curve. So we have to use this formula as well as some puzzle solving abilities to figure out how to find this area. So there's really no formulas that I can give you off the top of your head to say, do this every time and you'll get the right answer. All right. I really can't do that necessarily. You kind of have to, each one's like its own puzzle where you have to kind of put the pieces together to figure out how to find that area. All right. So first thing that I think I want to do is, we'll go through it here together, is I want to find these 2 points because these 2 points are where the 2 graphs actually meet. So to figure out the 2 intersection points, I'm going to have to take the two polar curves and set them equal to one another. So I need to know where 3 sine theta is equal to 1 plus sine theta. So I can subtract over sine theta if I want. And it gives me 2 sine theta is equal to 1, and divide by 2. I need to know where sine theta is equal to half to find them. So I know that sine theta is a half in quadrant 1 and quadrant 2. That would be pi over 6 and 5 pi over 6. So this angle here, this radial line, is pi over 6. And this one over here is the angle at 5 pi over 6. So now the question is, how do I find this area that I see up here? Okay, so I think the one way that's easiest to do this one would be if I could find the area of 3 sine theta between pi over 6 and 5 pi over 6. You can see how these 2 angles slice up this green circle here, right? That would find me all of this area. All of this. But I don't want all of this area. I only want the area that I see up top that I shaded in at the beginning. So to figure out the area that's shaded in, I would have to take away the area from pi over 6 to 5 pi over 6 that's in here. But that area is bounded by this graph, 1 plus sine theta. So that's what I'm going to do. So to find the area, I'm going to take 1/2 the integral from pi over 6 to 5 pi over 6 of 3 sine theta squared d theta. That will find me all of this area that's in black. Now, I want to take away from that area 1/2 the integral from pi over 6 to 5 pi over 6, 1 plus sine theta squared d theta. So I want to take away from that area this area here. Because if I can take away that area that's in yellow, then the only area left will be the area that's in red. And that's how you would calculate the area of that region that lies inside the one curve and out of the other. Okay? Again, you can type this into a calculator to do it. You might have to do it by hand if you're in Calculus 2. Calc BC, you can type it in a calculator. If you're in a Calculus 2 class, you might have to do it by hand. Chances are they probably wouldn't make you do it by hand, but you could at least set it up. All right? So that's how we're going to go about doing these. Each one is like its own miniature puzzle that you kind of have to piece together. Okay, let's try another one. I want to find the area that's inside r equals 3, so that's the circle. And also inside 3 plus 3 cosine theta. So the graph in red here is 3 plus 3 cosine theta. Okay, so now, what area is that? It's inside the circle. Well, that's the area inside the circle. And it's also inside 3 plus 3 cosine theta. So it has to be inside both. So that would be all of this area, that, and then all of this. I want to find the area of that. Okay. Now, part of this area is actually pretty easy to find. You can find this area really, really easily because this is a circle, right? With a radius of 3. It's a constant radius. So then this area is just a semicircle. So then the area of the semicircle would be 1/2 pi r squared, or 1/2 pi times 3 squared, which is 9 pi over 2. That's the area of the semicircle. But now I also need to know this small area here, this little area. Well, to figure out this little area, I need to know two things. I need to know where these two curves meet and where this curve has a value for r equals 0. Where this curve has a value of r equals 0. So let's go find both of those. So I need to know where 3 is equal to 3 plus 3 cosine theta. So I can subtract 3 over. So then cosine theta will have to equal 0 when I divide by 3. So theta is going to have to be, where's cosine 0? At pi over 2 and 3 pi over 2. Okay, so this up here is pi over 2. That's good. I mean, you can see it on the graph, right? But it's good to check. Now, the question is, what is this value here? So this value is where r is equal to 0 on 3 plus 3 cosine theta. So 0 will have to be 3 plus 3 cosine theta. So I'm going to subtract 3 on both sides. I get negative 3 equals 3 cosine theta. Divide the 3 out. Cosine theta is negative 1. So theta is going to be pi. So this is pi here. So now what I can do is, I already have the area of this piece here, this semicircle. Okay, I have that. And I'm going to show you another way to get the area of the semicircle in a minute. What I need to do to it, that 9 pi over 2, that's the area of the semicircle. I need to add to it, let's see. I'm going to find the area from pi over 2 to pi of this curve. So it would be 1/2 the integral from pi over 2 to pi of 3 plus 3 cosine theta squared d theta. But that's not all the area, because that's just the area from there to there. So that's just one of these. But there's two of them. There's another underneath. So I would have to take whatever this area is and double it, right? And add the 9 pi over 2, which would be the area of the semicircle. And that would give me the total area. And that is the correct answer. That's one way to give a correct answer if you don't have to integrate. Okay? The other thing you could have done, instead of finding the area of the semicircle, is you actually know, okay, here's pi over 2. I could do a couple of things. This value is 0 on that circle. So here's 0. So what you could do is you could find 1/2 the integral from 0 to pi over 2 of r squared d theta. But again, that would, from 0 to pi over 2, that would only be that, a quarter circle. So you'd have to double it to get the other piece. Okay? You could also integrate 1/2 the integral from negative pi over 2 to pi over 2, 3 squared d theta. That would give you the whole semicircle from starting down here all the way around to there. All right? That would also give you 9 pi over 2. So look, there's a lot of ways to do these. That's what I want you to understand. You have to understand that, hey, there's multiple ways to come up with the right answer. Not everybody's going to look at it the same way. Each one's its own little puzzle. You got to try to figure out what the pieces are, how they go together. Okay, let's try one more. We're going to find the area that's inside the curve r equals 2. So that's the circle. But outside of the curve, 2 cosine 3 theta. Well, 2 cosine 3 theta is the 3 petals that are here. So, well, the easiest, so I want the area inside of this, the circle, but not inside the petals. Outside the petals. So the easiest way to do this one, I think, is pretty easy to see. Find the area of that circle, then subtract out the area of the 3 petals, you'll get the area that remains. That's what we're going to do. So to find the area of the circle, you could do 1/2 pi r squared. That would certainly work. So that's 1/2 pi, 2 squared would be 2 pi. That's the area. All right, that's one way to do it. Okay. No, the area, no, that's not right. The area is pi r squared, right? Pi r squared. Of course it is. So that's going to be 4 pi. All right, there we go, back on it. Good. Okay, so the area of this circle is 4 pi. All right, that's one way to calculate it. The other way to calculate it would be you could take 1/2 the integral from 0 to 2 pi, go all the way around the circle, r squared d theta. That would also give you 4 pi. Take your pick. Both of them would work. And then I want to take that area, the 4 pi, and subtract away the area of the 3 petals. So how am I going to find the area of the 3 petals? Well, to find the area of a petal, I need to know, first of all, where the petal each is equal to 0. So I need to know where r is equal to 0 here. So I'm going to have to set this equal to 0. So we have 2 cosine 3 theta has to equal 0. Divide the 2 out. So cosine 3 theta has to equal 0. 3 theta will be equal to, cosine is 0. So the x-coordinate is 0 at pi over 2 and at 3 pi over 2. So if I multiply everybody by 1/3 here, theta is going to be pi over 6 and 3 pi over 6, right? Yep, and 3 pi over 6 is pi over 2. Okay. Now I can keep going. I'm supposed to go around 3 times, but really all I need to do is find the area of one of these petals and then triple it, right? There's 3 of them. So I could do that in a few ways. I could take 1/2 the integral from pi over 6 to pi over 2. 2 cosine 3 theta squared d theta, and then take that integral and triple it, because this integral is only one of these petals. I need to multiply it by 3 to get all 3. That's one way to do it. Okay, you could find the area from, right? So you could find the area from negative pi over 6 to pi over 6 and triple it. That would still be this. Okay. So again, there's a lot of different ways that you can go about doing this. All right. And that's what I want you to understand. Okay. Again, each one of these is like its own puzzle. Put the pieces together how you need to, find whatever areas you need to be able to find the area that you want. As always, thanks for clicking.